So now we've reached the stage where we need to introduce the concept of function composition, which brings us to almost the end of our functional programming chapter and expands our knowledge to put everything that we've learned so far into practice. Now we're going to be using currying for this. However, at the moment we do not need our curry function. So if you also want to go and just comment it out, this is all we need for this exercise, and then we'll bring back our curry function as we continue. Now what I want to talk about is the concept of function composition. You can kind of think of these as Lego blocks, where we can take multiple pieces and fit them together to make something bigger. That in reality is all you need to think about when you are composing your different functions. So what kind of things can we compose? First off, what I'm going to do is create a constant, and we're going to call this the slugify. Now all I'm going to do is assign a string value. Here we're going to do ultimate courses. Underneath we can console log the slugified value. What we want to do is basically turn this into a slug. Now a slug is not the creature, it is turning it into something that looks lowercase with a dash in front of it. So typically we would slugify some text to turn it into perhaps a URL. So that kind of gives us an end goal for what we want to do. So there's a couple of things that's going to happen here when we embark on this journey to achieve a lowercase ultimate dash courses. So the first thing that we could do is we could say that we want to split our string by the spaces. So if we go ahead, save this out, we now have an array. So now it's an array. What we could do is say .map. We could pass in each member. I can just call this X for now. It doesn't really matter what we call these. And then we can call to lowercase. Let's hit save. You can see that we've now got two lowercase. And let's go back on the end. And we're going to say join our array. Join will join each element inside the array with whatever we pass in. So we actually want a dash. So we're going to keep it nice and simple and do this. So this in fact gives us more of a functional programming approach. Here our split is a method, map we're then passing a function in, and join we're also calling with the dash inside. Now I don't know about you, but this feels like a nice functional approach already. However, these are just things that are built into JavaScript. They don't allow us to expand and use lots and lots of different functions to accomplish different tasks. However, the concept remains here in that we are using function composition to build a chain of events. So what I want you to think about is our input is this word ultimate courses, and then we're going to perform each operation in stages. So our map or join aren't going to call until split has finished. So we're going to have our new string, we're going to split it, after that we're then going to map it, and after that we're then going to join it. And it has to happen in that order. Now, instead of using the built-in split, map, and join, it's typical that when we use something like a functional programming library, such as Lambda.js or perhaps Lodash, we have all these utility functions built in. So we're in fact going to create our own. Now for this, we are going to bring back our friend curry, because we're going to curry each function so that we can partially apply it in a series of events. So the first thing that we're going to do, and we're not going to worry about the curry function just yet, but we'll create a split function with a separator, which is then going to return us a new function, which gives us a string, which that string can then be called with the split. And then we can pass in the separator. So this is our nice Lambda expression. It's a nice arrow function one-liner. It's also using a closure because we have to now call things twice. Now what I'll do is just comment this out. We don't really need it right now. To use our split function, we would do something like this. You can see that we need to pass in our separator. I'm just going to use a space. And now our split function is considered partially applied because we are calling just the first function. So this is in fact going to return us a new function that we need to pass in the string. So if I go ahead and say ultimate courses, we can in fact wrap this inside a console log and check out the value. Now we don't need our curry function just yet, so we'll just comment this out. So now you can see that we have our split and we are partially applying it. We're not doing a true partial application because we haven't curried this function yet. But essentially currying will allow us to add this behavior. So what we need to do is essentially merge both of these functions in because we want to keep our function a lot easier to read. So instead of having separator and then it returns a new function with the string, we're actually going to just have one function that accepts a separator and the string. Now, if we were to save this, everything blows up and breaks for us because we're now expecting to pass in the ultimate courses string as a second argument. So let's hit save, and now we're back to where we were. So this is really nice. However, we've now broken the rule of currying. We want to curry anything that we pass into, or potentially curry anything that we pass into our composition. For us to undo those changes and have something that works exactly like this, we need to then bring back our curry function, which allows us to wrap our lambda expression, our split function, and we're just creating split here as an example. There are lots of utility functions that we could go ahead and create, and this is what using a functional programming library is going to give you. So let's hit save, and we now have a fully curried function, which looks really nice to read. It's very simple. You can see the arguments that it takes. We're simply using some currying magic and then partially applying it here, and we're then passing in the final value of ultimate courses. So let's move on to the next helper method. We're going to create a join. For this, we're going to start off with our curry function from the get-go. Now, because we're joining, we're also going to use a separator and a string, and then inside we can simply say join the string with that separator. So that's nice and easy. Underneath, we can go and create a map. Now, map, you typically deal with an array, which when we use a string split, you can see that we have an array. So this is absolutely perfect. Now, this is just a high-level, simple example. The helper or utility functions that come with other functional programming libraries will be a little bit more advanced and a bit more bulletproof. However, these are absolutely perfect for us to get started with and learn. So what we've done is declared a function that we want to map over, and then we're going to declare our array. And we can just do array.map and then pass in that function. So this is nice and easy, and what this is going to do is then apply a transformation to every single element inside of our array. So ultimate is then going to have the function called, and courses will then have that function called too. Typically at this point we would do something like this, where I'm going to take our initial function call, and above here we're going to create a constant. So here we're going to say the split text equals, and then we're going to invoke that initial function. Now what we want to do is say const. We can call this the mapped text equals, and we can call our map function. Now what we're going to do here is pass in each item like we did down here, where we return x dot to lowercase. Now because we are inside of a map function, we are supplying the function as the first argument here. And what we need to do is now supply our array. So here you can see that we have split text. If we were to now log out our map text, what we need to do is just comment out our join just so it doesn't error. And you can see now that we have our mapped text, which is calling our map function above our curried function. It's taking our function and it's also taking our array. However, the split text, we're calling our function the normal way. So what we need to do is invoke it afterwards like we would in functional composition. Now, right now, what we're doing is learning step by step what it takes to compose functions. And yes, at the moment, it's actually a little bit more complex and a little bit more verbose. Now, I'm showing you this because when we compose a function momentarily, it's going to clean all of this up. It's going to be much easier to read, and I think you'll really like it. So let's create our final constant of joined text, which we can then say that we want to join. We can bring back our curried function with our separator. We can pass in our dash. Now the string that we want to join is in fact our mapped text. And then we can go and swap out our joined text and log it out. So now you can see that we have the full flow of what is happening. And to be honest, this is typical for when we are developing applications. We create these variables and then we can pass them into other functions. But I don't know about you, when I look at this, it kind of gives me a bit of a headache and I have to understand too much about what's happening. We have this split. I'm then calling the function. We have this map. We're then lowercasing and then we're passing something in. It doesn't quite make sense to me. Things can be improved to become much cleaner. Now, the first thing that we're going to do, instead of keeping all of our constants, I'm actually going to move these into a function to show you what it would look like if we were to compose our functions the plain JavaScript way, if you were, without using any function composition. So we can take each piece step by step and then paste it into the next. So we end up with something that's actually quite long. So again, you can see that we can save this out and everything is as intended. Now what I'm going to do is take this map function because I like this to lowercase and it feels like we can create a reference to it where we're going to say to lowercase. Now above here, we're going to create const to lowercase. Now this one we're not going to curry, we're just going to leave it as is. So this is just a nice simple lambda expression on its own. It doesn't need to be curried because we're passing it in. But because we're abstracting it slightly into a lambda expression, we can now pass it into any different functions that we like. So we'll save this out again. You can see that we have our code, and really this is not very helpful at understanding the flow of what is happening here. We also limit ourselves because we are calling our function with our ultimate courses string here. So what it might be better to do to make this reusable is to rename this to str, and then we can pass in any string that we like. So here, our joined text, we can now call this the slugify function. And down here, we're just going to pass in the ultimate courses text. So if we save this out, you can see that we've now moved the data outside of the function, and our small program made up of a few functions that we've composed together is now passing each result into the next function. And this is kind of how we can think about our functional programming. Now again, I just want to reiterate that this is typically more of a complex way of doing things. I think you'll agree that when we looked at this at the beginning, this is very nice and readable. However, it doesn't really solve our problems with functional programming. You'll also notice that we are kind of doing things backwards, and this is what functional composition gives us. We have our split function, and then our map function, and then our join function. So it's kind of inside out. And in the next video, we're going to look at function piping, which will then give us a much more enhanced readable way of doing things as well. So that's our nice slugified version. Now what I'm going to do is comment it out, because wouldn't it be nice if we could do something like this, where we say that we want to compose, and then we're going to simply pass in a step-by-step path for our code to follow. Now because our functions are technically calling themselves inside out, and we have to do this to pass each one to the next one, we need to actually pass in these in reverse order. And we'll come on to that momentarily. Now, what I mean by this is we need to pass in our split function. So we're actually going to mimic everything that happens down here, but because we're composing, we need to pass them in backwards. Don't worry, that'll make more sense as we continue. So again, we want to split. Now, right now, this is called a partial application, which is why we have just learned this in this chapter. We've dealt with closures, we've looked at higher order functions, and we've now looked at currying and how to partially apply a curried function. And that is where we come into our own, as our compose function is going to give us some superpowers with our JavaScript. So once we have in fact split things, we want to move on to the next logical step, which would be our map function. Now because we have our to lowercase, we can simply pass it like this. Now you may be thinking, why am I doing these backwards? Again, just bear with me. This is function composition. So what's actually happening here is we are creating some compose function. Now compose doesn't just exist yet, so don't worry about that just now. However, this is a much more readable approach to composing our functions. Now compose runs right to left, which is why these are in reverse order. In a minute, we're going to look at using a function pipe, which basically allows us to put them in more of a chronological order from the top down rather than the bottom up. But for now, let's continue with understanding function composition. Now really all that is left is one, logging out our slugify function, because our compose is going to return us a function which we can then call, such as this. However, we don't have a compose function or an implementation. Now with compose, this does exist in other functional programming libraries. However, like many of these things, we're going to create our own. So let's go ahead and const compose. We're going to ... functions. Now this is going to take any of these functions that we pass into our compose function, and it's going to convert them into an array. Now what it does is return us a new function. So when we call this function here, we're in fact returning a closure. We're not doing anything with these functions just yet. It's when we return the function to slugify and then call it, it's then going to kick off these chain of events. So keep that in mind. We are returning a new function. So we could say, for example, x. Now inside of this function, we are going to take our function's array, and instead of calling reduce, we're going to call reduce right. Now we'll set this up and then we'll talk through it. If we then add some characters for value and function, and then inside the body of the function, we're going to call that function with a value, and we're also going to supply this x as the initial value to the function. So that should in fact give us a fully working demo. You can see that we can go and change some of the text down here. So let's go and do ultimate JavaScript, and you can see that everything is working perfectly. So we are in fact using our compose. Now remember, these have to be in a specific order, which really is right to left. So first we're splitting, then we're going to map, and then we're going to join, which doesn't really fit in with many developer mindsets. So let's undo our changes and investigate our compose function a little further. Now what I like to do is take x, for example, and we can console log it right here. If you want to use this, this is a clever little technique where we can log out things in an arrow function whilst also running this piece of code. So you can see here that x in fact gives us whatever we call the function with. So this function is returned to compose. Compose then returns a function to slugify. Slugify then calls our function with ultimate courses, which is x in this case. Now x gets passed as the initial value to our reduce function, and that is actually very important. So because of this initial value, the v, which is our value, on the first run of the reduce becomes the text ultimate courses. So ultimate courses gets passed in, and then the next function calls it. So let's have a look. We have a split. So what's going to happen then? Once we've passed in ultimate courses to split, we're now going to get the split array as the next value. So the array is then going to get passed into map, and we're then going to call it with our split text. Then reduce right will take that value, pass it in back to us, and we can then call our join. And because we are partially applying these up front, they all get called sequentially in order at the right times using our function closures. So this is why it's so important to understand the concept of partial application, because you can see how readable this is. We are partially applying these functions ahead of time. However, nothing's really happening. Nothing's being kicked off until we in fact call our function here down below. Now I just want to reiterate a few things. Compose is in fact returning us a function. So we could in fact call it like this. We can save things out. You can see everything is as normal. So this is typically the signature for what a compose function does. You can pass in your functions such as this. These will then get passed into our compose, and then we just need to call our compose function with the data that we want to then process. Now, obviously, if we were to call the function like this, it doesn't become reusable. So keeping our slugify function as it is and being able to log it out like this keeps it very usable. And we can do this a few different times. We could put your name in there, for example, and then everything works perfectly. So you can see how the power of function composition, when we're using these utility functions, we can simply compose in just a few lines of code something very readable. Now, the only thing that slightly bugs me is the fact that it's not as readable as a left to right. And this is where a function pipe comes into play. So when we use compose, remember it's right to left, and we're going to look at a pipe function, which is left to right. So this has been a mighty video so far. We took our curry function, we curried a few basic implementations of some nice operators. We then looked at a small lambda expression for just a nice reusable lowercase function that we could pass into various other functions. We then looked at how we could compose with a very long-winded and complex looking function signature that looks quite confusing. We then introduced a very nice compose function which uses reduce right, and it keeps passing the next value. So as soon as ultimate courses gets passed to split, the result from split gets passed to map, the result from map gets passed to the join, and then our function simply exits. So that's it for this video. I hope you really enjoyed this. I absolutely love talking about currying and function composition. And again, I just want to reiterate why it's so important to understand what's happening with our currying. And of course, we have this alternative way that if we wanted to call our helper utility functions in a non-curried approach, we can absolutely do that as well. So the functions here are giving us a lot of power. We can use them both ways. We can jump in and out of a functional programming paradigm relatively easily by using a curry function on perhaps an existing function elsewhere in the codebase. So that's it for this video, and I will see you in the next one where we're going to discuss the differences between a compose and a pipe function.